Hello guys, I am Flash Isaac. I recently introduced calculus, where I explained that calculus is a branch of mathematics that studies or try to explain how things change. It is from the Latin word small stone, and the branches of calculus are the limit of a function, differentiation, and integration. I've already talked about limit of a function. I've explained differentiation and integration. Today, I'll be taking you through the applications of differentiation. Where are the areas differentiation find application? This is the topic for today. Before then, if you've been following my differentiation and integration videos, where we know that integration is the reverse of differentiation. If a function is differentiated, to get it back, you integrate. So integration brings back what was differentiated. As a revision, remember from differentiation, if y is equals 3s squared, the y ds is simply equals 2 times 3 s raised to the power of 2 minus 1. We multiply by the power and we subtract 1 from the power. This is differentiation of algebraic function. This gives us 6s. How about integrating 6s? This will give you 6s raised to the power of 1. We've not changed anything because any function or any number still is raised to the power of 1. Integration says instead of subtracting 1 from the power, add 1 to the power. And instead of multiplying by the power, divide by the power. This is why integration is the opposite of differentiation. So you simply come here and say 1 plus 1 over 1 plus 1. Where differentiation says 2 minus 1, then 2 times 3. This simply gives you 6s raised to the power of 2 divided by 2. 6 divided by 2 is 3. This is equals 3s squared. So integrating this, we get 3s squared. This has proved that to get what was differentiated, you integrated, and this is equals this. If you don't understand, feel free to go through the differentiation videos because everything is explained there. Also, if y is equals 3 sine 4s, to differentiate this, it is simply we bring out the constant, then you differentiate sine 4s, 4 cos 4s. When you differentiate sine, you get cos. When you differentiate cos, you get minus sine. So this is simply 3 times 4 cos 4s to give you 12 cos 4s. And integrating this, remember, instead of multiplying, we divide by 4 to have 12 sine 4s over 4. 12 divided by 4 is 3, which is equals 3 sine 4s. Integrating this. Similarly, when you differentiate 2 cos 3t, you get minus 6 sine 3t. Why? When you differentiate cos, you get minus sine. How about integration? When you integrate cos, you get sine. When you integrate sine, you get minus cos. So integrating this, you simply get 2 cos 3t. Then for exponential function, if y is equals 3 exponential 5s, dy ds is equals 3 times 5, 15. So 15 exponential 5s. You simply multiply by the power. How about integration? To integrate this, we simply divide by 5 instead of multiplying to give you 15 exponential 5s divided by 5. This gives you 3 exponential 5s. So we've been able to revise differentiation and integration and the relationship between differentiation and integration. Let's go to the main topic of today, which is application of differentiation. One major application of differentiation is finding the gradient of a curve. gradient M is simply equals change in y over change in s. Remember, I explained that for every graph, you have the s-axis and you have the y-axis. So to get the gradient or the slope, you simply look for change in y divided by change in s. What is change in y? Change in y is simply the final value of y minus the initial value of y, which is y2 minus y1, where change in s is simply s2 minus s1. So gradient or slope is equals change in y divided by change in s, or y2 minus y1 divided by s2 minus s1. Now look at a graph like this. In your examination, after plotting graph, you see points on the graph, and for most graphs, some points don't need to enter. Let's say there is one outside, one here. So you just try to draw a line to pick at least 2 points. Have something like this. Choose any of the 2 points in the graph. In this case, let's pick this and this. What do? From here, draw a line down. From here, draw a line here. You formed angle 90. What are we looking for? We are looking for change in y divided by change in s. We are looking for y2 minus y1 divided by s2 minus s1. In this case, what is y2? If this is the y-axis and this is the s-axis, it simply means that the values here are y and the values here are s. Since we picked 2 points, let here be first point and here be another point. Any point from here down is the first point or the first value of s. We can call it s1. And any point here is the first value, second value of s. Let's call it s2. And going to this direction, any value here is the first value of y, which is y1. And moving from here down, assuming this line is straight, any value here is the second value of y, which is y2. Meaning in this graph, this point corresponds to when y is equals 8. So y2 is equals 8. This point corresponds to when y is equals 2, which means the first value of y, y1, is equals 2. Looking at the s part, this point corresponds to when s is equals 1. Therefore, s1 is equals 1. How about here? For this, 4, 5. If this line is straight, this should come here. Or let's assume this is it. So it simply means that s2 is equals 5. What next? We substitute into the formula. Gradient is change in y over change in s. Gradient is y2 minus y1 divided by s2 minus s1, which is equals 8 minus 2 over 5 minus 1. This is equals 6 divided by 4. This is equals 3 divided by 2. This is the answer. Let's assume you don't understand the whole grammar here. But from here, it says where the curve has 2 as a gradient. This means gradient here is 2. So 2 is equals change in y over change in s. Or change in y divided by change in s is equals 2. Or y2 minus y1 over s2 minus s1 is equals 2. Now let's continue. Where the curve, this is the curve. So the curve is when y is equals 2s squared minus 2s plus 3. Look at something. Looking at gradient, gradient is also equals dy over ds. So when you differentiate a function, what you arrive at is also the gradient of that function, giving us three ways of finding gradient: differentiating, finding dy ds, gradient, changing y over changing s, gradient equals y2 minus y1 over s2 minus s1. So if y is equals 2s squared minus 2s plus 3, what is dy ds? Dy ds simply becomes, differentiating 2s squared, we have 2 times 2, 4. 4s, subtracting 1 from 2, we have 1. So that is it, we've differentiated. Minus, when you differentiate 2s, you get 2. I already explained that because 2s is the same thing as 2s raised to the power of 1, right? Then multiply 1 by 2 to give you 2 times 1, 2. Subtract 1 from the power. 1 minus 1 is 0. S raised to the power of 0 is 1. In fact, in mathematics, any meaningful number raised to the power of 0 will give you 1. So this is why when you differentiate any value or any number with s, the s goes, the number remains. Plus, what do you get when you differentiate 3? You get 0. When you differentiate a constant, you get 0. Differentiation of 100, you get 0. 1 million, 0. 20 million is 0. So this is plus 0. Rewriting, we have that dy over ds is equals 4s minus 2. Remember, we are told that the gradient is equals 2, meaning changing y over changing s is 2, dy ds is equals 2. So we can change dy ds to 2 because they already told us. Substituting, we have that dy over ds is equals 4s minus 2 is equals 2 from the question. From here, collecting like terms, we have 4s is equals 2 plus 2. As minus 2 crosses, it becomes plus 2. So 4s is equals 4. Dividing both sides by 4, s is equals 1. We found the value of s. Remember, the question says we should find the points s and the point y. So the point s is 1, like we found. How about y? To get the point y, we simply substitute s into this equation. So y is equals 2s squared. Instead of s, it becomes 1, giving us y is equals 2, 1 raised to the power of 2 minus 2. Instead of s, 1 plus 3. This becomes 1 raised to the power of 2 is 1. So we have 2 minus 2 times 1 is 2 minus 2 plus 3. This gives you 3. So y is 3. These are the points. If you are using it to, if you are pointing it out here, you simply have s to be 1 here, y to be 3 around here. So this is the point. So that is it for gradients of a point. How about finding maximum and minimum points, or finding rates of change? Let's take a look at that. The second application of differentiation is finding the minimum and maximum points, or we can say finding the turning points. This is the principle you must follow while looking at minimum, maximum, or inflection points. Inflection points. Take note. At the turning points, dy ds is equals 0. At turning point, the y ds is equals 0. For maximum or at maximum point, this square y over ds squared must be lesser than 0. This what shows that the point in question is maximum or the maximum point of the curve. While for minimum point, d square y over the s square should be greater than 0, which means it should be positive. These are the conditions when it comes to maximum, minimum, and for inflection point. For inflection point, d square y over the s square must be equals 0. What is the meaning of d square y over the s square? It stands for higher derivative or second derivative. If y is equals 2s raised to the power of 3, dy ds is equals 6s square. D square y over the s square has to do with differentiating the second time. So when you differentiate this the second time, it is simply 12s. This means d square y over the s square of 2s raised to the power of 3 is equals 12s. That is second derivative. So for turning point, dy ds is equals 0. That is turning point. Looking at this question, it says at what value of s is y equals s raised to the power of 3 plus s squared minus s plus 1 minimum or maximum. So what is the maximum or minimum point? When you are given questions like this or a question like this, whether you are asked to look for the maximum point or you are asked to look for the minimum point or you are asked to look for the inflection point, these are the steps you must follow. First, find the turning point, which is dy ds. What is y? For this, y is equals s raised to the power of 3 plus s squared minus s plus 1. This is y. Dy ds is simply differentiating y. When you differentiate y, what do you have? You get 2s 3s squared 3 times 1, subtracting 1 from the power, 3s squared plus 2s minus 1. This is dy ds. And remember, at the turning point, the y ds is equals 0, meaning this is dy ds 3s squared plus 2s minus 1 is equals 0. If in this case dy ds is equals 0, we've been able to get a quadratic equation. What do you do to quadratic equation? You solve or you factorize to get the two values of s, s1 and s2, or you can call the first value s and the second value y, or what you choose to do. Factorizing this, we have, you look for what you can multiply to get 3 and add or subtract to get plus 2. This becomes 3s squared plus 3s minus s minus 1 is equals 0. So this is it. If you don't understand, I will share a link to my quadratic equation video that will help you better. From here, we factorize 3s, 3s squared divided by 3s. This is s plus 1. Here, minus 1 common. Minus s divided by minus 1, it gives you s. Minus 1 divided by minus 1 is plus 1. Plus 1 is equals 0. Since this and this are the same, we pick 1. Then we take this also to have 3s minus 1, s plus 1 is equals 0. And anytime you are giving two brackets together equals to 0, it simply implies that this is equals 0 and this is also equals 0. So the solution to this equation becomes 3s minus 1 is equals 0, or s plus 1 is equals 0. If 3s minus 1 is equals 0, it means 3s is equals 0 plus 1. It means 3s is equals 1. It means s is equals 1 over 3. Or s is equals 0 minus 1. S is equals minus 1. What have we done so far? We've been able to, from the turning point, we've been able to get the two values of s, So you ask yourself, which of these value is maximum or minimum? Remember, this you can't get them from here. So any answer you get here, don't assume. So we know that S is equals 1 over 3 or S is equals minus 1 from the turning point. What is the minimum point? Minimum point is when you look for d squared y over the s squared and the answer is greater than 0. That is when you know the point that is minimum, or whether the point is maximum or minimum. In some cases or most cases, you won't arrive at quadratic equation here. You will just get a single value of s. Now, to know whether that single value of s is maximum or minimum, you look for the second derivative and substitute. This is it. This is dy ds, right? You look for d squared y over ds squared. This is equals, when you differentiate this, you get 6s plus 2. Differentiating a constant is 0. So this is d squared y over ds squared. Substitute these values into d squared y over ds squared. Putting 1 over 3, we have that d squared y over ds squared is equals 6 1 over 3 plus 2. This is equals 6 times 1 over 3 is 6 divided by 3. 6 divided by 3, that should be 2, right? So yes, so this is 2 plus 2 equals 4. Now, here, d squared y over ds squared is greater than 0. It is 4. 4 is greater than 0. This means at s is equals 1 over 3, we have a minimum point. So the minimum point is 4. And that minimum point occurred when s is equals 1 over 3. So let's see the point that minus 1 is. If d squared y over the s squared is this, substituting d squared y over the s squared is equals 6s plus 2. At s is equals minus 1, this is 6 minus 1 plus 2. 6 times minus 1 is minus 6. So minus 6 plus 2. This is equals minus 4. Now, in this case, d squared y over the s squared is lesser than 0. Because minus 4 is lesser than 0. The maximum point is minus 4 and the minimum point is 4. So we solved. Now, if in a case or a situation where you look for d squared y over ds squared and you substitute the value of s, if it gives you 0, that is the inflection point when d squared y over ds squared is equals 0. So how do you find maxima and minima, or how do you solve for maximum and minimum point? First, you find the turning point. You differentiate the equation given, you equate it to 0. From there, you find the value of y, s, t. It can be any variable. When you get that value, sometimes it's a single value. Other times is you get two values, like in quadratic equation. From there, find the second derivative of the function. After looking for the second derivative, substitute the values you get into it. Anyone that gives you a positive answer, that is the minimum point. The one that gives you negative, less than 0, that is the maximum point. And if it is equals 0, that is the inflection point. So that is it. And for rate of change is simply differentiating dy ds or gradient. So given question like this, if v is equals 4 pi r squared, what is the rate of change of volume with respect to r squared? What you simply do in this case is differentiate. In rate of change, so long you know the formula or you are given the formula, it's simply to differentiate. That is it. In this case, this is constant, this is constant. So with respect to r squared, it means we differentiate just here. Assume here are constant, like not the constant that will be equal 0. Assume they are not there. We are facing this. You simply say v is equals 4 pi. When you differentiate r squared, you get 2r. This is simply 8 pi r. You found the rate of change. So that is it for applications of differentiations from the gradient of a curve to stationary points, maximum and minimum points, and rates of change. I hope you found this class helpful. I am Isaac, and don't forget to subscribe to this channel for more amazing videos. Feel free to check out my other videos. Have an amazing day.